Hello everyone, this video topic is the memoryless property. It is an important property of exponential distribution. The content is that I will introduce the exponential distribution introduced in chapter 4 once again. Then the topic memoryless property is introduced, and we have some examples. The exponential distribution it means the probability distribution of the time between event in a Poisson process. For example, the distribution can be used as a distribution of recovery time or both waiting time. When the average event occurs, which is a parameter of a Poisson process, is lambda, and the PDF of the exponential distribution is as follows. That is lambda multiply, it is a natural constant or Euler constant to power minus lambda multiply x, and the x means time, and lambda is the average of the event occurrence. Each range is greater than or equal to 0, and the parameter lambda is greater than 0. Okay, and it is denoted by the x follow exponential distribution with the lambda. Okay, where the lambda is called the instant rate parameter. Okay, then the CDF, it means the cumulative, the probability function is like this: 1 minus e to power minus lambda multiply x. Okay, looking at the example 1, suppose that the time until a patient recovers from surgery follow exponential distribution with a mean of 10 days. Okay, that is there is one patient, and we follow after surgery, and we are interested in their time until recover. Okay, time. And we know that the mean of recovery time is 10 days, so the lambda is 1/10. So random variable x follow exponential distribution with the lambda equal 1/10. Therefore, question 1, the PDF is the 0.1 multiply exponential e to power minus 0.1 multiply x. Okay, like this. And the CDF, that is cumulative, the probability function equal 1 minus e to power 0.1 multiply x. Okay, so question 2, what is the probability that the recovery time of the patient will take more than 50 days? That is the probability x greater than 50. So using the complementary rule, so minus 1 probability x 50 CDF when x equal 50, so 1 minus 50. 50. Okay, equal. So the probability is CDF is the 0.2231. Okay, so when the lambda equal 1 over 10, the exponential the distribution is like this. Okay, then in the question 2, this area is the 0.231. Okay, in this situation, the doctor say that it will take at least 5 days to recover from this surgery. Okay, in other words, when this surgery is performed, there is a condition that it takes more than 5 days to recover. So question 3, what is the probability that the recovery time of the patient will take more than 5 days? That is, it is a probability that it takes more than 15 days under the condition the time greater than 5. Okay, so in the question 3, the probability of the condition probability is greater than 5, then x greater than 50, right? And by the definition of the conditional probability, that is the denominator is x greater than 5, and the numerator is 50, intersection 50. The numerator is equal the probability x greater than 50. Okay, so 5, 50. Okay, means that 1 minus f5 is 1 minus f50, so 1 minus so equal 0.3679. Okay, and we can also express it like this. This 50 and 5 and x greater than 10 plus 5, the condition x greater than the 5. Okay, and is the probability x greater than 5 equal exponential e to power h equal to 1. So they'll cancel out. Okay, equal 1, 10. It means the probability x greater than 10. That is, we can summarize. This continuous probability equal to probability x greater than 10. Okay. In the question 4, what is the probability that the recovery time of the patient will take more than 20 days? So the probability x greater than 20 and the condition is x greater than 5. Okay. It is the 5, the numerator x greater than 20. Okay, so exponential minus 0.1 multiply 5, exponential 1 multiply 20. So it is the 0.2231. Okay, yeah, you can also express it, the probability x greater than 50 plus this 5 and x greater than 5. Okay, so either cancel out equal Mr. x greater than 50 equal 0.2231. Okay, like this. Okay, so that is the probability x greater than 20, the condition x greater than 5. This the conditional probability equal the probability x greater than 50. Okay, to sum up, there is a 2 time point t small s. The probability, the condition is x greater than small s, then the x greater than t plus s equal the probability x greater than t. That is, the condition does not affect the probability of the next occurrence time. Okay, that is not depend the past memory. Okay, depend independent. Okay, it is called the memoryless property. So it refers to the case when the distribution of waiting time until a certain event does not depend on how much time has elapsed already. Okay, let x have an exponential distribution for the 2 times the t and s. The memoryless property is like this. Okay, the proof for this is as follow. Probability x greater than small t plus st condition x greater than small x equal the probability x s intersection as inner the probability intersection equal the probability x greater than t plus s. Okay. So the s minus so it cancel out, so it means the x greater than t. Okay, so in the example 1, the question 3 is that the probability x greater than 50, the condition equal x greater than 5. Okay, so it equal x greater than 10, 5, x greater than 5. So the it means the past memory. Okay, so using the Memoryless property of the exponential distribution, so equal probability x greater than 10, no, minus 0.1, 10 equal 0.3679. Also in the equation 4, equal x greater than 20, then equal it means the past memory, so it just the probability x greater than 5, exponential by 0.5 multiply 50, 0.2231. Okay. Let's looking at other example 2. You're waiting for a bus that arrives according to an exponential distribution with a mean of 50 minutes. If you have already been waiting for a minute, what is the probability of the bus arriving within the next 10 minutes? Okay, you know, so the time x as random variable x, and x follow exponential distribution, and the mean is the 50 minutes, so the lambda equal 1 over 15. So the probability is that the x greater than okay, first you know, the if you have already been waiting for a minute, so x greater than 8 minutes, and the x greater than 8 plus the next 10 minutes, so 10. Okay, so equal you know, they're using the Memoryless property. it is the x greater than just 10. Okay, so equal f 10. So 1 minus e to power minus lambda equal 1 over 50 multiply x equal 10. So e to power 10. So easier 0.5134. You know, the probability distribution is like this. The lambda equal 1 over 5. And start 10 this area. Okay. Okay. So example 3. Suppose that you have a big project. That is, you are modeling the time until your company goes bankrupt. Okay, and assume that the time to bankruptcy can be modeled using an exponential distribution with a mean of 5 years. That is, the x follow exponential distribution lambda equal 1 over 5. Okay, x means the time until company goes bankrupt. Okay, that is the A company. We follow that we are interested in the time until bankruptcy. Okay, so now the company has been in business for 3 years without going bankrupt. So what is the probability that the company will operate without bankruptcy for the next 7 years? So the probability is that the condition is x greater than 3 and x greater than 3 plus 7. Okay, you know, so using this property, the probability equal the x greater than just 7. So the exponential e to power minus 1 over 5 multiply, that is 7. There we go, 0.2466.